Welcome, everyone. The brave few of you who have come to hear me talk about full stack Clojure. We're in the back-end track, but we're talking about front-end and back-end stuff here. In fact, you're going to see just the tiniest bit of back-end code because I'm going to talk about the front-end a lot today. And I often give talks about how amazing Clojure is and why it's a great thing to use and whatnot. This talk is a little different because it's not about, oh, Clojure is neat. It's about, oh, we have a problem and Clojure's one solution to it. So the problem that exists is, this is what the web used to look like. Here's the first website. Lots of web pages still look somewhat similar, but fewer and fewer as time goes on. Web pages these days look more like this. These rich applications that people are using that they aren't documents, they're this new thing. Maybe not new anymore, but still, they gain more and more complexity over time and become harder and harder to build. As you can see, browsers over time have changed. It used to, your browser maybe ran a little JavaScript, maybe had a little CSS, not exactly what happens these days. You get a lot more, mainly because of this, actually. And it's funny, the one I didn't put up here is the original Outlook.com, where we actually got the XML HTTP request from. It was invented by Microsoft to put so they could make Outlook.com run. But you have your, you had your webmail up to this point, which was just like every other web application that we've ever built. I assume everyone in here has done some back-end web development. How many people have written Perl CGI scripts? Wow, I am like shedding tears right now because only one person raised their hand, because that's where I got my start for sure. And up until this point, most applications you saw, you hack a few CGI scripts together, you throw them in there, you go from page to page. It tends to work. And then Gmail came out, and suddenly people went, oh, there must be a different way to build web apps I don't know about yet. And of course, this article came out in 2005, which was sort of the thing that got most people looking at the idea of having really interactive JavaScript applications. When Adaptive Path came out with this article about Ajax, people started to realize, oh, I can have web pages that are constantly updating. I'm not shifting people from page to page to page. I'm not using normal requests that you would expect, but I'm doing things all interactively. Cool enough. We got stuff like jQuery and whatnot to do this. But as soon as this hit, 2005, the number of pages that looked like that first web page from the number of pages that looked like Gmail went straight up. And so we got some things to work with that. We got some frameworks. And here's some of the ones that I have used in the past. So those first couple of ones you look at there, you're looking at OpenLazlo, GWT, all those were, okay, you already know something, just use that. And this whole web thing, pretend it doesn't exist. Just put it down there and pretend that we've never seen that before. And then we got things that were more actual webby, JavaScripty. We got jQuery, we got Move Tools. We got this Backbone, Angular. Lately we've had React come out, which I've enjoyed using quite a bit, I have to say. But all of these got more and more complexity. If you've ever built has anyone built a large Angular app? Or even a small Angular app? Has anyone read Angular documentation at all? Let's go with that. It's a little complicated. I think of myself as, I've been programming for 20 years. I think I know what I'm doing. I can't understand a word of it. I look at it and I go, I don't know. I don't know what's happening here. I make this face, the stock photography slide. So why? Why, in order to have these rich web applications, things have to be this hard? I started out programming when I was about 10 in BASIC. And over time, I remember when I went from my IBM PC Junior, my first computer, which I loved, to IBM, I think it was called a PS2. And then Visual Basic 1.0 came out. And it was magical. It was this incredible world. I could draw things on the screen and hook stuff up to it and go, oh, yeah, when you click this button, do this. Okay, when you click this button, do this other thing. Save this somewhere. And it was really easy. I couldn't believe that GUI programming was that easy. And now I can't believe how hard it is. We've doing things that aren't that much more complex than I was doing then, but we're doing on the web, and the tools to do it are very, very hard. Now, granted, some of them are much easier. jQuery, it's a very easy technology. Love using it. Use too much of it and it begins to fray and become this giant mass of spaghetti and callbacks. Backbone, not too bad, but again, you run into limitations. You're like, oh, I'm not going to sync data the way Backbone normally syncs data. Well, good luck. Now you're going to write a bunch of code. Angular, like I said, is just, to me, and I realize many people use it very well. To me, I read it and I go, I don't begin to know what's happening here. And Ember is, I feel like I'm walking on embers when I read the Ember documentation. It's really not something that my smaller mind can grasp. So a couple of friends of mine looked around and said, there's got to be a better way to do this, right? How do other people manage this in other areas? Well, Clojure is going to be part of the solution, but it's not all the solution. So he went with this idea called Hoplon. Hoplon is a web framework for Clojure that I'm going to talk about that solves this problem. So Hoplon uses Clojure and ClojureScript. If you haven't heard of ClojureScript, it's Clojure that compiles to JavaScript. It's the same language. Clojure is a sort of a parasitic language. It lives on top of other runtimes. So Clojure runs on top of the JVM. ClojureScript runs on top of JavaScript. They're used, and these two things together with Hoplon, you can build a single-page application that it is greatly reduced in complexity. And that's sort of the rallying cry behind most Clojure libraries is how do we reduce complexity? And that's what Hoplon attempts to do. So, Clojure is a Lisp, and a lot of times when I give a Clojure talk, I start with syntax, first thing first. But I'm not here to tell you Clojure is cool. I'm here to tell you Clojure can solve a problem for you. So Lisp is syntactically quite different from what most people use. I imagine a lot of people in here have used JavaScript, C. You're familiar with C-style syntaxes. And it's not the same. I think a fear of syntax is sort of the hobgoblin of small programmers. Syntax is something that people can learn to deal with. But this is the first thing that people run into when they first look at Clojure and they go, wait, there's parentheses everywhere. What am I going to do with this? Behind those parentheses is something really powerful and great to use. You have a functional language that knows how to deal with large-scale applications, multi-thread applications, lets you do a lot of very cool things. Clojure came out in 2007, and ClojureScript came out in 2012. I'll go ahead and tell you the bad thing about ClojureScript right now is that it's one of the most poorly documented things I've ever seen in my life. But luckily, Hoplon is not, and Clojure itself is not. So if you haven't used Clojure before, and who in here has touched Clojure in any way? Okay, so a few people, cool. So this is probably not new to you. For some of you, it may be. Clojure uses what's called prefix notation. Every time you're going to call code, you start with parentheses, and you have a function in there. In this case, that plus sign is a function. So plus 1, 2, 3, it's analogous, same thing as plus 1, plus 2, plus 3. Your data, you have a couple of different data structures. Like in here, we have an array, starts with square brackets. You have functions. You define them, they look a little different, right? We have def in there, and then say hello, and then you have some arguments that are there in square brackets. Then you have the body of your function. That function is exactly the same as the JavaScript function beneath. The two work exactly the same way. And you can call any function, just like we saw up at the top with plus 1, 2, 3. You can open your parentheses, put a function name, put its arguments, and you've called it. Easy peasy. So Clojure code, in practice, ends up being eerily familiar to other things we use as web developers. So this is actually, this is straight from a slideshow, some code I have to generate slideshows. And if you look at this, does it remind you of any other language that you've ever worked with? At all. What if I replaced the parentheses with angle brackets, less than and greater than? Would it start to look like anything else? It looks like XML because it is a lot like XML. The core of Lisp languages are called S expressions. The way you write it, this open parentheses, and then the function name, and then a bunch of arguments, closing that, that's called an S expression, and it's incredibly similar to the way we write XML, and specifically the way we write HTML. So first of all, as a web programmer, generally I'm using 4 languages at any given time. I'm using HTML, CSS, JavaScript, and some backend language. Well, let's eliminate one of them at least. You can write any HTML as S-expressions. It works exactly the same. So here I've got an H1 written as an S-expression, a list written as an S-expression. It's not really, there's not a real difference in verboseness, but okay, I'm already collapsing this a little bit. So if I can eliminate part of my problem with I can do things all in one language, that's cool. Hoplon gives me this ability to do this. That by itself isn't that useful. What is useful is that all of those elements that we know from HTML are now functions. And with functions, we can do other things. Anyone who's used JavaScript for a while already has an idea of how you can pass functions between other functions, first-class functions, right? You can reuse them in other contexts. Well, that's sort of the core of Clojure. So here, up at the top, and I realize now in retrospect that that blue on top of black is a little hard to read, so my apologies for that. But right here, we have a new function called QuickList that takes any number of elements, makes an ordered list, and then uses a function called map. Map, you may have seen if you've used underscore JS. I think there's a map function that comes with jQuery. Or if you use Ruby, you have map on your arrays there. Python, there's a map. Perl, there's a map. You've seen map. All map does is says, take a collection and run a function on every element of it and give me a new collection with those results. So here, I can now call QuickList and give it 2 things, and it'll go ahead and create the UL and LI for me. That's cool. That's nice. If I were to go back to this right here, well, that would be cool. Maybe I could have that emit my body and emit all my divs, and let's say I was using, what's the really big JavaScript slideshow thing? Forget the name of it, but I wrote this in order to do that, Reveal.js. So this right here could convert into a bunch of HTML code, but I'm writing it in the language of what I'm actually doing. I'm making a slideshow, so why not write it that way? Or I'm making a web application that should be showing mail or updates or whatever it may be. Okay, if I can write it in that language, then that's great. If anyone's used Angular, you've seen something similar with Angular directives, lets you make these custom elements. And in fact, because any HTML can be written as S-expressions, there's no reason why we shouldn't be able to write S-expressions as HTML. We have to deal with people who aren't using Clojure all day, right? We have our designers, we have other people on our team, front-end engineers. Maybe they want to write some HTML instead of writing S-expressions. What if we could do both? Hoplon makes that no problem. You can do it either way. So right here, once I've defined that, I can use this QuickList as an actual HTML element. And lo and behold, when Hoplon gets a hold of this, it calls it as a function and emits the result. So I get out what I would expect to get out. So that's pretty cool. I had to throw spans around it because there are a few differences between HTML and S-expressions. While in my S-expressions, I'm able to use strings. There's no string element in HTML, so I had to put a span around it to do that. But for the most part, I've got the same thing back and forth here. But that doesn't solve the whole problem of single-page applications. That just solves a little problem, which is how can I talk about the UI of my application in the language of the UI instead of in somebody else's language. It's very cool to be able to do that, but it doesn't solve the problem of I have data on a page, I have UI on a page, I need to update them, I need to get stuff from somewhere else, I need to make a million asynchronous calls. I have now a giant pile of mess. So looking at every single page application you've ever used, you quickly realize, okay, interactivity is sort of the core of this. How do I give it input and make it affect data? And how do I have the changes in that data affect the output? But generally, those 2 things you have to do separately, right? So if I'm going to make a page that when I have a remote form submit, and it's going to tell me, I'm making a comment form. I go in and type in the comment and hit submit, and instead of going to another page, it's going to say, oh, it was submitted, and let me show it on the page. But the steps I have to take there are myriad. First of all, I have to probably validate my data. Okay, I'll do that, but let's even throw that out. I have to take the data from my form, because a form is in HTML, and it expects that it's probably just going to submit. So I have to override that and now add a click event or a submit event to the form to say, okay, get the data from the form, so pull out those values, send them asynchronously back to a server. When I do that, let me know whether it's successful. If so, then update my UI and take that data that I've just sent you. Maybe you sent it back to me, maybe not, I don't know, but take that and display it on the page. So I have this like dance of data in UI that there's no way of actually knowing, like, are they in sync? I have to make sure that my code is perfect to make sure they stay in sync at all times. And that's just on a very simple remote form submit. When I get into something more complicated, like here I am dragging and dropping a bunch of tasks. I don't know, has anyone ever used a Pivotal Tracker or Trello, for example, right? So you're dragging and dropping tasks lots of places, and other people are too. And that's going back to the server. So now your dance of like UI and data is even more complicated because your data is getting updated by someone else as well. And when your data gets updated, I need to update my UI. That is exceedingly complicated. And it expands the more that you add. It gets a sort of geometric complexity. When I add a new UI element to my page, I need to make sure that all of my data, any piece of it that changes that could affect that, will update it. And if I add a new piece of UI that can update my data, I need to make sure that every single piece of data that could be updated by it is, and then every piece of UI that can be updated by that data is. And when you have many pieces of UI that can be updated by the same data, that just gets into this huge amount of complexity. So how do we do that without like having this giant framework of code, whether it be adding an MVC model on top of it, or writing a god-awful amount of JavaScript to handle it, or whatever. It ends up that people have been doing this since the beginning of computers, and it's not hard. Spreadsheets. Spreadsheets are sort of the bane of a lot of people's existence, I realize. I used to work as sort of the head of IT and programming, because that happens when you're at a small company in Louisiana. One day someone came to me and said, hey, I need you to make a PDF out of something. A customer sent me an ad. I went, okay, that's cool, no problem. And the ad, it came to me in Excel. They used it as a layout program, right? So spreadsheets, Excel has been like the program that's used for everything and anything that it probably shouldn't be. People get frustrated with it all the time, but there's a key inside there, whether it was Lotus 123 or Excel or whatever spreadsheet program you've used in your life. There's something in there that's really amazing, and that is data and UI are inextricably linked, and the dependencies are handled. So when I have a couple of cells on a page, and then I have a bunch of calculations based off them, I can have calculations based off of cells that have calculations, based off of other cells that have calculations, and I can have that out in a tree, and the dependencies are just handled. It's very, very simple. It's not a great UI, just having a page of rows and columns. We don't want to do that, but there's some lesson in there. So, like I said, okay, it's a very popular model for representing data. And the dependencies are easy to track and are followed automatically in there. Easy for most people to understand. And if it's easy for most people to understand a spreadsheet, then for us as programmers, and we're trying to figure out those dependencies ourselves, it should be easy for us to understand. I'm going to take a sip of water here. One thing that's sort of key to this idea is that in spreadsheets, changes come from a user, and that updates all the UI, right? So when that comes in, all your UI is updated. You have that one direction. Like Lisp, which is shunned by most mainstream programmers, so are spreadsheets. I don't know many people who, I can mention Excel to that don't immediately sort of shudder and make that face. And I would too. I mean, again, I have received, an ad laid out in Excel. So I know how much it can be abused. But you don't have to use Excel to get the idea of a spreadsheet across and to get an idea of a spreadsheet into your code. So part of Hoplon, part of its sort of family of libraries that make it up, is a library called Javelin. And Javelin takes this spreadsheet model, and it's not just for ClojureScript, it also works with Clojure, but it takes this spreadsheet model and adds it into the programming language. So before you look at this, a brief note about Clojure itself. In Clojure, data is immutable. So I can add, or I can take a name on data and give it to some other data. But what I can't do is take the data that I have stored in the name and just change it out from underneath it. So if I have an array, and I've given that array the name of numbers, I can't add something else to the array. The array is set. Now I can make a new array with that plus something else. I can give it a new name. I can give it the old name. I can do whatever. What I can't do is change it. It's set forth through some very specific constructs, and that's part of what makes the language very powerful. So this cell concept is using the same constructs, and that is normally this is called an atom. A cell works a little differently. But you can see, moving down here, I've defined a cell. I've added given an initial value of 0. To deref it is to get the value out of it, because it is a reference to that value. So that'll give me the value out of it. Reset will allow me to atomically reset it. So anybody else that's trying to access it at that time, they're not going to get it in an inconsistent state, because I'm atomically updating it. But what you do even more often is you call swap. Swap, you give it an atom, or in our case a cell, and you give it a function that is going to change that. In the same way that, if all of us, I think, have seen the classic, here's an example of how multi-threading gets crazy. When you have two threads and each of them are updating a global variable, adding one to it, and it does it 200 times, and at the end of the program, you run, and it says, oh, it only updated 150 times. Why? Well, because they were getting the value and then adding one to the value, and the value would change before they were able to add to it. And so two people just added one to the number 100 and put it back on the stack there. So these atomic updates prevent that. So that's what swap is doing here. Is it's saying take our cell and atomically update it, get the value out, and run this function on it, and then put that value back in. But cells aren't just value cells. We have value cells in spreadsheets, we have value cells in Javelin. We also have formula cells, and that's what you see on the second line here. So I've defined a new cell called times 5, and it takes our first cell, multiplies it by 5, and that's a formula that's in there. So when I go in and I update counter to be 1, then times 5 is going to be 5. That is going to atomically happen as well. It's going to use the formula to figure out what the data should be in there, just like you would see on a spreadsheet anywhere else. So with that, I'm going to show you this in action, because I think slideshows, while pretty, are not where it's at. I think actually seeing code is where it's at. So let's see this. I am just, by way of example, because I want a piece of code that's easy to sort of comprehend and go through, I've made an example using Conway's Game of Life. Are people familiar with Conway's Game of Life? Is anyone not familiar with Conway's Game of Life? Feel free to raise your hand. No one is going to laugh at you about that. Okay. Well, I have a room of people who love Conway's Game of Life. So let's just, here I have, I've written this in Hopline, Conway's Game of Life. Yay, it's doing stuff. We've seen this 100 times, but let's look at how it works in Hopline. Because before we see it in Hopline, let's talk about it for a second. I've got a UI here that's a grid. I've got things that are updating on that grid, right? My cells that are alive here are stepping through generations, and I have a new set of cells that are alive. So traditionally, what I would do is I would run some sort of function on the set of cells that I have to find out what the next generation looks like. And then I would update the UI. I would have another piece of code that goes through my UI and says, okay, things that were alive before that are now dead, you're dead. Things that were dead before that are now alive, you're alive. Update all that, then go to the next thing. With the Hopline model, how does this work differently? So this is some Hopline code. You'll see here, I'll make it even bigger. You'll see here it's closure. There's lots of parentheses. Don't be scared yet. And I'm defining some things in here. I defined the size of my grid. But I also started to define cells. So this def C just creates a cell. That's all that's doing. But I have a couple of cells here. One's called running. I've set it to false at the beginning. I've set an initial value for my cells. So I have two gliders and an oscillator on the page. In Conway's Game of Life, gliders are, we know what gliders are, I think. And then I also have some stuff about key presses. I have just two simple functions here that calculate my next generation. That step function calculates my next generation. That is some really terse code. If this was to talk about how much I love Clojure, we would spend the rest of the talk on that code. We're not going to do that. Just trust me, that code gets me to the next step. I would love to walk through it with you sometime, even during questions. But what gets cool here is this. Let's move down here. So right here, with init, it says, okay, run this stuff when the page initializes with interval 500. So every half second, when running. So remember, running is a cell that starts with false in it. That @ sign in front of it just dereferences it, so it gets the value out of its cell. So when running, then swap cells, what I have in cells, with a run step on what I currently have there so I can get the next generation. Nowhere in there have I written code to update the UI, okay? There's no code to update the UI so far. So here, this starts to look like HTML because it's just written in ClojureScript. So I've got HTML, head, whatever. Here's where it gets interesting. I have ID here, GOL, game of life. And then I have two list comprehensions to go through and populate my grid. In here, I'm saying, okay, make 40 rows, give them IDs, and then inside each of those rows, make 40 more divs for each of the cells. And the class is a cell. So where I have that colon class there, that's called a symbol in Clojure. It's a lot like, or it's called a keyword in Clojure, actually. It's called a symbol in Ruby. It's really easy to get those two confused. I've added an anonymous formula cell. So here it says, okay, my class is going to always have cell true, so the cell will be one of my classes. And then alive, that's going to be me a true or false depending on whether my current cells have that element in it, XY, the current XY. So if my cells, which I saw up here before, you see here on this line, these cells, and these are just XY coordinates, they're pairs of XY coordinates. That's a set that they're in, so an actual real set, not an array. So if that pair of XY coordinates is inside this data structure, which is a cell, then have my class, sorry, it's right here, have my cell have the class alive, okay? And then also, when I'm not running, that onClick says when I'm not running, then I can add new cells, make new cells alive or dead. When I'm running, don't let me alter it. Because this is in an anonymous cell, that means that class is going to update whenever my data changes. Because remember, I have cells. Think about this mentally as a spreadsheet. I have one cell that has, here's all of my, things that are alive and dead in it. And then I have another cell that says, or I have, in this case, 40 times 40. So I have 1,600 formula cells that say, hey, I'm either alive or dead depending on the data that's over in that other cell. Figure it out. And whenever I update that first cell, all 1,600 of those other cells will update. And in fact, that's exactly what happens. This is all the code that it takes to have this. I'm going to refresh the page so you can see the initial state. There's the initial state. Okay, it's running. So every half second, I update the data in my cell that has all of the, I just realized the word cell is used in both Game of Life and in Hopline here. That got kind of confusing. But when I say cell, I'll talk about the Hopline cell, and I'll just say blocks here for the Game of Life cells. So my cell that has the data of which blocks are alive is going to be updated every half second. And when it's updated, the UI is updating automatically just based off classes because my class is an anonymous cell. So that just automatically happens. I don't have to do anything to make that work. I think that's pretty cool. I'm pretty excited about that. The code that I would have had to write to do a similar thing just using HTML and CSS and say jQuery, I would have had a lot more code to say, okay, go through here and change things and update them and do stuff. I realize there's data binding that works in other frameworks as well that could do something similar. This is the Hopline way of doing it. I think it's a lot less code and a lot simpler to get your mind around than some of those. But that alone, this is a pretty simple web application. Anyone could build this, and there's no back end at all. So let's see something a little bit more complicated. So what I would really like to do, in Game of Life, you have different boards you could play it on. A lot of times to make things simple, people will use what they call a toroidal board, a donut. So when you get to the edge of the board, it goes back to the other side, whether it's on the left side, right side, top or bottom, it just loops around. But the Game of Life is really made to have an infinite board. And in fact, I do here. You can see if I make a glider here, that it's going to go off the board pretty soon. I probably should have put it closer to the edge if I wanted it to go off the board soon. So keep going. It doesn't loop around. It just keeps going. But there's no way to prove it's out there. You have no idea. What I really want to do is be able to explore this board, see the infinite grid. Well, let's do that. In fact, let's look at it in the browser first. So now I have an infinite grid. Let's put another glider over here. Cool. So that glider's going off the board. I really want to see that glider, so I'm going to hit right to go that way. Cool. I have an infinite grid. I can go up and down, left and right as much as I want, see the entire infinite grid. Let's see how I did that. So the code is fairly similar to the last one. I've got a few new things. I've got some new cells here. I have a cell called OX and OY. OX and OY, all those are is the origin X and origin Y. Like my top left corner, what's the XY coordinate of my top left corner at this given time? That's all that is. So it starts with it being 0, 0. I added a debounce function because I'm going to need it for pressing some keys. And the rest of this is the same, except for I have some key bindings now that says, hey, when I when I hit up, then call this function called key press, which will show you saw the little up arrow and down arrow. It'll show you that. And then it's going to swap out the origin X or origin Y, either incrementing it or decrementing it by 1. So I'm just going to update those cells. Well, now my UI, all I changed to my UI was where I calculate, alive here. It's not just, why am I having some sort of, oh, I know why. There we are. Where I calculate that, all it's doing is it's saying take, the pair of coordinates x and y, but also add the origin x and origin y to those. So that what's in this cell is not, just because this is cell 2, 2, doesn't mean that 2, 2 shows in it. 2, 2 plus whatever the origin is shows in it. Right? So if I've moved 2 over and 2 down, it's 4, 4 that's showing in it. And then also, my own click, I've changed it so when it toggles a cell, it takes into account the origin x and y there. That is all I have done. I'm in development mode in Hopline, so it automatically refreshes my page when I change my code there. That's all I've done, yet it's given me the ability to look over an infinite grid, which I don't even know how to approach normally. Again, I'm not the best programmer, so I need something like this to make this easy for me. Cool, I now have an infinite grid, which is, to me, awesome. I can't believe how easy it was to jump from that step to the next step. The other things I added in this step were space lets me start and stop, which I already had, and also it lets me just go forward a step now, so I can sit here and hit this to go forward a step. That's all that's doing. Now, there's another piece of UI that got added, this up and down arrow, left and right, and it fades out after I quit pressing it in a little bit. So what did I do there? Well, I added a few more cells. And that's how you deal with all UI changes in Hotline, is you just add some cells to deal with it. So now I have a cell called last key and show key. Show key is false, so don't show the key unless that's true. Last key right now is empty. And my function key press, it goes and it resets that last key. And it resets show key. So it says, oh, put the last key that actually pressed in there, and then say show key true, and call hide key press. All hide key press does is it resets show key back to false in 2 seconds. Debounce is just a helper function to say, hey, you can reset this. So continue to reset that interval as long as I keep telling you to hide it, right? So it doesn't try and hide it after every key press. It's after I haven't pressed a key for 2 seconds. But all that's doing, again, is changing data in a cell. It's not saying anything about the UI. The UI itself talks about it. So down here, I have this attribute doFade toggle. DoToggle is what you normally see. DoFade toggle just lets you have a little fade action on it because I like the pretty. But it says, okay, do toggle based off the value of show key. So if show key is true, show it. If show key is false, don't show it. If I change to false, then fade it out. And then there's a little bit of, that text element there has a little interpolation in it that's automatically going to dereference the cell for me. So make sure that you put the last key that was pressed in there. Again, that last key, it's not saying, hey, look at the last key that was pressed to put in there. It says, hey, put the value of this cell in here. If that cell value changes, then this changes. And that's automatically hooked up for me. I'm not explicitly telling it to hook it up. That just happens because it's based off of my data. So cool enough. I like this. But so far, what I haven't seen is using any other JavaScript. So this would be really cool if I lived in a walled garden where all I had to do was Clojure and I never had to touch anybody else's JavaScript. But that's not true in most cases. I really do need to use other people's JavaScript lots of the time. So I would love to be able to save and load boards in my application. So I made one more here. It's got 2 new UI elements, a little old school save button and load button. Works the same here. I can start and stop it. I can go in and make some new stuff. Cool, that works. I would really like, I've got my board in sort of a weird state here. What I would like to do is, I'd like to load my original board. So let me load starting here. Cool, I got my original board. Or what's even better is a glider gun. A glider gun will continue to make gliders and yet stay, it doesn't ever stop existing. So now you can see one glider right down here going down the page, and another one will come soon. Now what happens if I add another glider here that will crash into that? I'd really like to see what happens. But more than that, I'd like to be able to show it to others. So I'm going to click Save here and say that I want to give this, Big Crash is the name I want to give this board. Okay, cool. Yeah, so let's let it run again. In fact, let's just move it forward a lot. Cool. I want to go back and reload that. Let me reload that. Big Crash. There we are. Cool, I'm back to where I was. So this is the first time that we're doing 2 things. First of all, we're using external JavaScript, and this is the first time, well, my apologies there. This is the first time you're seeing something that's actually traditionally full stack, because it's using a back end. So let's see what that looks like in Hotline. Maybe it's way more complicated, and everything that we've seen so far that's been simple is just, overly simple, and this is really complicated. But I bet it's not. Okay. So I have a couple of things here. I'm using, the name of the modal library that I'm using is called Vex. So in here, I have, during my initialization, I'm setting some stuff in Vex so I have the right theme. Okay, that's fine. And then I have some new functions called load board and save board. And I'm calling out to Vex through here. Save board is a good example because you can see here I'm calling .prompt on there. Again, you're looking at Clojure, which you're probably not familiar with so far, so It may not be as readable as seeing it in JavaScript, but that's what we're doing is the same thing as in JavaScript if I had said this right here, bats.dialog.prompt, message, what name, right? I put a space there. It's the same thing as this JavaScript. So I'm going to call into it. I have a little method called CLJ to JS. It's turning my closure into JavaScript data structures. But I'm doing the same thing. I'm able to use closure functions inside here and just have it work. So my callback is a closure function. But yeah, that's going to work just fine. Load board is a little bit more complicated in that it's going and getting a list of boards from somewhere. You can see right here, it's calling RPC/boards to go get that. But how is it doing that, right? That's the full stack part. Well, I have some closure code this is all the closure code I have for this, but it starts with a couple of boards and then lets me save some other ones in here. And it starts with something called def RPC, make an RPC function. We live in a world where often we were building REST APIs and whatnot, but right now I'm building something that, and I can use whatever I want on the back end with Hopline, but right now I'm just building something that I want my front-end application to talk to. So why not just use a sort of traditional simple RPC model? These automatically get exposed to my application so that I can do something like, say, for name board in RPC/boards, right? So get my boards and show it to me, and that's going to happen by making a call back to the server. That is a whirlwind tour of Hopline, but the things that I think are great that I want you to take away from it are the simplicity of the spreadsheet model, how linking immutable data to UI and then updating that data through an atomic process makes things very, very simple. Those are the two main takeaways from Hopline. And with those, it doesn't matter what programming language you're using. You can implement this same sort of thing in JavaScript, or maybe you use some other language that compiles to JavaScript. But whatever language you use, you can re-implement this. I just happen to like using it in Clojure because Clojure is an amazing language that I love using. So you can go to hopline.io, and there's a really good walkthrough tutorial on using Hopline. You can find me on Twitter, ClintonDreisbach. And the presentation was co-created between me and Alan Dipert, who's one of the two creators of Hopline. Alan is great, and you can find him on IRC and the Hopline channel very, very easily. He's always on and answering questions, including a million of mine, because it is still a fairly new technology. So with that, what questions do people have?